Friends, we are back for Applied Math Daily Lesson number 2 here. Today we're also going to be looking at solving single variable equations. All of the equations I'm going to have today will have only one common variable, x, y, z, a, b, c, whatever the letter is going to be. We'll be looking at systems of equations here in a few weeks that have multiple variables. The difference in lesson 2 here compared to daily 1 is that our variable terms you're going to see on both the left and the right side of my equation. So I'm first going to, as I did in daily lesson 1, is simplify both the left and the right side of the equations. If I can combine like terms, distribute, do any operations to do operation cleanup, that would be a beautiful thing. So as I look at 7x plus 19, unlike terms, variable, constant, negative 2x, variable term, and 55, constant, I can't put any of those together. So what I'm going to do here is to get my variable terms together, collected, moved on one side of the equation. Preferably, we can move what we call the smallest or coldest of the two variable terms to the other side. Why? Well, it's always easier to move something smaller. Would you rather move a pile of 2 bricks or 100 bricks? Obviously 2, because it's smaller, less work. So with 7x and negative 2x, the negative 2 is smaller or colder than positive 7. So I'm going to, again, use inverse operations. What I do unto one side of the equation, I must do unto the other. Negative 2 plus 2, x's are gone, 7x, 2x, 9x on the left side plus 19 will equal positive 55. I'm going to subtract 19 from both sides now to get my 9x alone. I'll have 9x equals 55 minus 19. Ooh, that's tricky. Well, what's 55 minus 20? 35 plus 1, 36. So 9x is 36 divided by 9 on both sides. We've got x equals 4. Good. Example 2. We've got 90 minus 9y is equals 6y. We're going to move the smaller, the colder, negative 9y over by adding 9y to both sides. Negative 9 plus 9, y is our adios on the left side. We're left with 90 equals 6 plus 9, 15y. Doesn't matter that the y is over here on the right side. We can undo multiplying by 15 with dividing both sides by 15. 90 divided by 15 is 6. That'll equal y. Hopefully we're rocking and rolling here. So far, so good. Example 3. Whoa, Nelly, we got one here that needs a little cleanup on both the left and the right side. So as I scan through the left side of 5x minus 3x plus 4, I can see two x terms here that I'm going to put together. 5x minus 3x is 2x. I still have plus 4 will equal 2x and 1x on the right side are going to combine to make 3x. And I still have plus 8. All right, now we're ready to move and groove. My x's, I have a positive 2, positive 3. The 2 is smaller, so I'll subtract 2x from both sides. Left with 4 equals 3 minus 2, 1x plus 8. Last step then to get our friend x alone is subtract 8 from both sides. Negative 4 will equal x. Example 4, your friend and mine, the distributive property is going to have to be utilized to multiply my 4 outside in on the left side of the equation and my negative 2 outside in on the right side. So I'm going to go 4 times 1 is 4. 4 times negative x, negative 4x, plus 3x will equal negative 2x. And then don't forget that negative 2 times 1 is negative 2. Any like terms? Well, for negative 4x, positive 3x. So I can put these x terms together. I have 4, and then negative 4 plus 3 is negative 1x. That'll equal negative 2x minus 2. We'll move the smaller. You're saying, whoa, I thought negative 1 is smaller than negative 2. Remember, you're thinking temperature. Negative 2 is further to the left of 0 on the real number line than negative 1. 2 below is colder than 1 below. So I'm going to add 2x to both sides. Still have my 4. Negative x plus 2x is 1x, and that'll equal negative 2. Last step then, we've got our x here. Subtract 4, and I'll end with x equals negative 6. Take a quick TO, get the final 4 examples fired up here in just a moment. Let's get the final 4 examples gone through here. We're going to take a look at our good friend, the F word, a fraction example, the dirty D word, decimal example, and then we're going to look at a little geometry connection with angle measures within specific triangles. So example 5 here, we are going to take a look at B variables that are going to have some fractional coefficients. Left side of example 5, I'm going to have to first multiply my 1/2 outside in. 1/2 times B will just be 1/2 B. 1/2 times 6, half of 6 is 3. That's going to equal 3/2 B minus 1. Now I look at my fractional values, 1/2 and 3/2. 1/2 is smaller, so I'll subtract 1/2 B from both sides. So I'm going to have 3 equals, if I have 3 over 2 minus 1 over 2, notice I have a common denominator here of 2. So I'm just going to take 3 minus 1, which is 2 over 2, B minus 1. Well, 2 divided by 2 is just 1. So I have 3 equals 1b minus 1. Add 1 to both sides, 3 plus 1. 4 will equal b. Kind of a fun example there of my fractions canceling out in a sense. All right, example 6 before we talk triangle values here, we're going to see that I have 0.5 and 0.3y. These are like terms. So I'm going to have 0.8y will equal 0.4y plus 10. My smaller y is the 0.4, so I'll subtract 0.4y from both sides. 0.8 minus 0.4, 0.4y will equal positive 10. Dividing both sides by 0.4, I'm going to get y equals, you might have to think here, 10 divided by 0.4. Well, 0.4, if you think of it as a fraction, is the same as 2/5. I'm just doing this in my head. You're probably going to use a calculator and be much more efficient than me. But you're thinking, oh, it's 10 divided by 0.4 is 2/5 as a fraction. So I'm not going to divide the fractions. I'm going to multiply 10 times 5 over 2. So 50 divided by 2 should be 25. That's kind of goofy. I'd recommend using a calculator. 10 divided by 0.4 and get 25. Okay, we're off to our geometry connection here. We have 2 triangles, one right triangle, and then one, I believe, isosceles triangle. We'll have 86 and then 2 identical angles here, which mean the opposite sides are congruent. So isosceles, acute triangle. All right, example 1. I need to recall that in a triangle, there are a total, if you add all angles together, there are 90, and then my two other angles together also need to make 90. So I'm going to have a total of 180 degrees in my triangle. So my right angle here is 90, and then my other two need to add up to 90. So that gives me my 180 total. I'm not going to make this any more challenging than it has to be. So I'm just going to write down my three angle measures. I've got a 90 here, my right angle, plus I've got a 20, plus I've got a 3x plus 10. And I know these need to sum to 180. My like terms here on the left side, 90, 20, and 10. 110 and 10 makes 120. So I got 120 plus 3x equals 180. Subtract 120 from both sides. I'll have 3x equals 60. Divide by 3, and x will equal 20. I can check now to make sure that my angles sum to 180 degrees. 90 and 20 is 110. 3 times 20 is 60, plus 10 is 70. So I got 90, 20, 110, and then this full angle here is 70. 110 and 70 does make 180. Groovy. All right, example 2, the grand finale here of today's lesson. We're going to have our top angle, 86, plus my two base angles, each x. They need to add up to 180. X and x make 2x. So I've got 86 plus 2x will equal 180. Subtract 86. And I'm going to have 2x equals 180 minus 86 will be 94. Divide by 2. X will be 47. There you have it. Lesson 2 notes in the book. Have a great rest of the day.